This Zoom session is being brought to you by the Fractal Bullseye Fire. Oops, let's see, it should be this one. Yes, okay, here we go. Yes, for today, we go on about combining functions. And 2728, we'll talk about inverse functions. Okay, so we start with two functions, f of x and g of x, and we'll define their sum, their difference, their product, their quotient, and their composition. Sum, plus, minus, times, and divided are defined term-wise, namely f of g at x is f of x plus g of x. F minus g of x at x equals f of x minus g of x. F times g at x is f of x times g of x. And f over g at x is f of x divided by g of x. The last one is when g of x is not zero. And all of them are defined also only when f and g are both defined. So what we call intersecting domains. So intersecting domains here and intersecting domains here plus g is not zero. We define their composition, written f o g, I read it as fog, it's f of g. It's defined this way. F of g at x is f of g of x. Basically, you apply g to the number x and then f to the result. So it's a sequence, a chain of functions. Start with x, define f of x, g of x from that, excuse me, g of x from that, and f of g of x from that. That double motion is called f of g of x. So some examples. Here's f of x is 2 divided by x, g of x is 4 divided by x plus 4. What's the sum, difference, product, and quotient? Well, it's easy enough. The sum is 2 over x at x is 2 over x plus 4 over x plus 4. For x not equal to 4, 0, or negative 4, because those are where these components are not defined. Their difference, f minus g, is evaluated at x at 2 of x minus 4 over x plus 4. Again, for x not equal to 0 or negative 4. F times g of x is 2 of x times 4 over x plus 4. We can simplify that a little bit as 8 over x times x plus 4. So there we go, x not equal to 0 or negative 4. And finally, f over g of x is 2 over x divided by 4 over x plus 4. If you flip this quotient in the denominator and multiply across, you get 2 times x plus 4 over 4x. And okay, you could simplify that further by canceling the 2's and get x plus 4 over 2x. And again, this is defined for x not equal to 0 or negative 4. Now here we have a function root x plus root of 1 minus x. What is its domain? Well, this part is defined for x at least 0, and this part is defined for 1 minus x at least 0. So x at least 0 and 1 minus x at least 0. And this translates to x less than or equal to 1. So this is defined for x between 0 and 1 inclusive at both endpoints. Now here we have the composition function. F of x is 3x minus 5. G of x is 2 minus x squared. What's f of g at 0? What's g of f of 0? Well, here's what we do. F of g of 0. Well, you find g of 0 by substituting in. That'll be 2 minus 0 squared. F of 2 minus 0 squared is f of 2. F of 2 you plug in here. 3 times 2 minus 5. End result, 1. Fine. Now here, g of f of 0. Well, let's see. F of 0 is 3 times 0 minus 5. That's negative 5. So we have g of negative 5. And g of negative 5 is 2 minus negative 5 squared. 2 minus 5 squared. Well, negative 5 squared, but the negative cancels out. Page 3, negative 5. I should put that change that in the canvas. And okay, after a bit of arithmetic, that's negative 23. Notice that f of g at 0 and g of f of 0 are not the same. So order of operations matters. It's called non-commutativity. Okay, here we have f of x is 2x plus 3. G of x is 4x minus 1. What's f of f? What's g of g? What's f of g? And what's g of f? I'll evaluate at x, of course. Okay, so here we go. F of x is f of x. And f of x is 2x plus 3. So this is f of 2x plus 3. Now, we apply f to 2x plus 3, meaning that we multiply it by 2 and add 3. Twice 2x plus 3, that plus 3. After a bit of arithmetic, that's 4x plus 9. G of x is g of x is 4x minus 1. G of 4x minus 1, and g of anything is 4 times it minus 1. So 4 times 4x minus 1, that minus 1. And after a bit of algebra, that's 16x minus 5. F of g of x, like this, is f of g of x is 4x minus 5. F of something is twice that thing plus 3. So twice 4x minus 1, that plus 3. Plus a bit of algebra, you get 8x plus 1. G of f of x, that's g of f of x, that's g of 2x plus 3. And g of something is 4 times that thing minus 1. So 4 times 2x plus 3 minus 1. Distribute the 4 and combine terms, and you get 8x plus 11. Once again, the order of operations counts. F of g of x is 8x plus 1. G of f of x is 8x plus 11. Here, f of x is x minus 1. Here, g of x is root x. Here, h of x is also x minus 1. What's f of g of h? Well, so it's f of g of h of x. H of x is x minus 1, so it's f of g of x minus 1. G of something is the square root, so f of square root of x minus 1. F of something is a thing minus 1, so you get root of x minus 1, that minus 1. Okay. That concludes that part.